Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Alireza Najafi-Yazdi, founder and CEO at Anyon Systems. Alireza and I spoke about their full-stack quantum computer company that tackles everything from cryogenics to qubits to software, how to keep quantum computers running without attaching a technician to each one, and much more. I hope you enjoyed this episode. Hello, Alireza, and thanks for joining me today.
Hi, Yuval. Thank you very much for the invitation.
So, who are you and what do you do?
Well, I'm Alireza Yazdi, and I'm the founder and CEO of Anyon Systems, and we are a quantum computing hardware company located in Montreal, and we also have some satellite presence in Waterloo region in Canada as well.
And I apologize, but I want to say I'd never heard of you before, but I only heard of you very recently, and then I found out that you've been out in the market for active for a number of years. Is that by design, or is it just my ignorance?
It is to some extent by design. We actually started in 2014 and really like officially launched the company in January 2015. Um, and In that regard, we are one of the oldest companies in the quantum computing market. I think older than us, perhaps Rigetti by a few months, and maybe D-Wave by quite a few years. Uh, and it was around that time that John Martinez and his team joined Google, and the Google Quantum effort started, and IBM also started their recent superconducting effort. So yeah, we're almost as old as the industry is.
And I think you're building a complete system, both the hardware and the software and everything in between, using superconducting qubits. Is that correct?
That is correct. So we're pretty unique in some aspects, and that is we build every major component of a superconducting quantum computer in house. We build our own dilution fridges, which I've noticed shocks many people. They don't expect a quantum computing hardware company to be able to build its own dilution fridge. We build our own control electronics. We build and develop our own firmware stack, and we kind of stop right at the SDK. That's when we hand it over to the client and other partners to build, compilers or sophisticated algorithms and whatnot. So that's where we're primarily focused on the hardware and the peripheral of a quantum processor.
That sounds like a major undertaking. I think there are very large companies who try to do full stack solutions. Can you give me a sense about the size of your company, how many people, or what kind of funding that make it possible to do a full stack solution?
Sure. We're 25. We're not too large a group. We're 25 people, but we've been at it for quite a long time now. It's more than 7 years, almost. In December, that's going to be 8 years of working on this project. So that we have a nimble and very efficient team. But we also took some time to build all this stuff. It took time.
And I think you have a quantum computer that actually works, that you've sold a few. Is that correct?
That is correct. So we have a system that we built for DRDC. This is a Canadian Defense Research Establishment here in Canada, part of the Department of National Defense. And That's a 6 qubit machine. That's the extent I can disclose. And we are now in the process of building a second unit. It's actually a very nice and commercial unit for data centers, and that's going to be installed sometime next year, hopefully the first half of next year, at Calcul, Quebec, which is a supercomputing center here in Canada, and that serves a number of universities here in Canada. So yeah, we're in the process of building that system, and the first phase of that system, we're going to install a 12 qubit chip, and the system is, as I speak to you, where almost all the major hardware components are either on the floor or they're being integrated. So we're going to start testing in the next couple of months.
What makes your system different or better than other quantum computers and specifically other superconducting quantum computers? Do you have, doesn't sound like you have more qubits. Are they better qubits? Are they better connected? Are they designed for different use? Help me get the differentiation, please.
There are two things, Yuval. One is, so here at Anyon, our activities follow two prongs. One, we have our own internal R&D that is focused on a very particular type of architecture and superconducting qubits and a novel qubit architecture that we're following. And the other, I think, avenue, the other stream of our work for the time being focuses on delivering, near-term intermediate scale machines, NISQ machines, to data centers and early adopters. So these two machines that I talked about, they feature that NISQ architectures. They are transmon qubits. They are tunable transmon qubits with tunable couplers. To some extent, similar to the architecture that Google has followed. We follow the same philosophy in many aspects. We like that philosophy very much. Of course, on the control electronics level, cryogenics level, these are essentially, and also even on the quantum processor, there are certain things that are very unique to ours. What we have been striving to achieve is higher gate fidelity and minimal crosstalk. So we on the crosstalk, we have really state of art, performance metrics. You can put the crosstalk, literally speaking, to zero, and performance metrics in terms of gate fidelities. Consistently, we're getting performance metrics which you can call us among the top three players in terms of performance of the qubits, and they're getting even better and better as time goes on. And scaling up the number of qubits is no longer an issue. We can scale up to few dozens, let's say to 60, 70 qubit with the existing platform that we've developed. It's just a matter of check size of the client, because building these machines costs a lot of money and somebody has to pay for it.
I was looking at the website and some of your press releases, and it sounds like the two of the customers that are mentioned are the government or defense related customers. I'm guessing that these customers are not using it on, a public cloud like a Bracket or Azure. Is that by design, or it just happened this way that the first two customers are government customers?
Uh, Part of it happened by design. It's just a philosophy that we have in terms of how an eventual quantum computer would be used. We think a quantum computer is going to be a hardware accelerator. It's going to be sitting next to a classic high performance computing infrastructure. So I mentioned Calcul Quebec and the supercomputing center. So we're very excited because this machine that we're building for them is going to be directly coupled into their existing HPC fabric to Narval, which is the largest public supercomputer here in Canada, and the 81st largest supercomputer in the world. So there's a lot of interesting integration work being done between the HPC and the quantum computing infrastructure we're building. And because of that, putting a machine on the cloud and having a TCP/IP API call, that's just slow. We don't think that's how a machine would be eventually used. We understand these are smaller scale machines, perhaps mostly for education and trying, proof of concept. But nevertheless, you want to really move toward the right direction. So that's why we didn't go directly to cloud. And there's also, when it comes to cloud, the business case has not been there, or at least I'm personally not convinced about the cloud yet. Building a machine costs millions and millions of dollars of capital. And then you put it on the cloud and you charge the client few cents a shot. And I'm not sure if you get return on investment anytime soon. And at the end of the day, we're a commercial company. Unit economy matters, and that's why it was so far has not been commercially attractive enough yet.
How about uptime? When I look at computers on the cloud, they're not up 24 hours a day. You know, they have limited or sometimes larger, but they have windows of operation. When you deliver a computer to a customer,
Yeah.
is that do you have to deliver a technician that tweaks the qubits every day, or how are these computers maintained?
It's a very good question. And this is one of the things that has been the subject of significant activities here at Anyon. We've been working on developing automated calibration systems that, as you said, tweaking. Yes, you need some calibration. You need regular calibration, perhaps 24 hours or even shorter time interval. And you don't want a technician next to the machine. You want this to be done automatically. So there's a lot of quantum control concepts, software, engineering concepts has gone into building the infrastructure to make sure that these things can be maintained without direct interference by sysadmins or our technicians. Particularly this one that is going to the supercomputing center, there's a lot of interesting requirements in terms of maintaining it. The uptime should be 24/7 for long periods of time. So it is so far we've run our machines for month and month, without a problem. Typically, we have to just warm up to swap a new generation of chip. So we've been able to maintain these machines up for quite some time, and we'll continue to monitor and learn from that experience.
Given that you are a full stack company, do you need any help from any other industry player? I mean, if you were controlling the quantum computing industry, what would you have people do that they're not doing today, or do to help you move faster?
Well, we're not definitely controlling the industry, but we were kind of controlling our fate and our technology, and that's been always the idea. Uh, and But there's a lot of room for collaboration. As I mentioned to you, we're so focused on the hardware that we strategically have decided to let others take care of algorithms, perhaps compiler optimization, things of that nature. I think this is a great area of collaboration. Benchmarking is another great area of collaboration. Those who have a particular expertise in benchmarking and they want to go from one hardware to another, they're more than welcome to talk to us, and we would love to hear from them as well. That's another great area of collaboration, and there's in between a lot of components that either we don't make or we don't want to make anymore that we love to see a supply chain for. A good example is dilution fridge. For example, dilution fridge. We When we started in 2015, there were just two companies at the time that you could call them commercial. One was Blue Force, and the other one was Oxford Instrument. And we were not sure, if they were bought out by our competitors, by these big giants, what would be our fate. So we decided at the time to it makes both a strategic sense and also for long term, if we want to go larger and larger number of qubits and build bigger and bigger systems, to have our own dilution free systems. We're probably going to keep some of these very key equipment or key components internally, and build them internally. But we're always on the lookout to see what others can do and take some load off of our shoulder.
And in terms of applications, do you feel that your computers are best for one particular type of application, like optimization or chemistry or something else, or really is the entire spectrum for you?
We build what's called universal quantum computers. These are gate-based machines, and in theory, you can run any algorithm you want. You're just limited by the coherence time of the qubits, and the gate fidelity is the same as you were running on, let's say, IBM or Google's machine. Um, that being said, a good question is what's the best application for quantum computer? And there's also some companies who are following application specific quantum processor architectures, and interesting discussion is what is it, what is exactly that, and how would that play out in the long term. So for the time being, we believe it's good to remain as generic as possible. So we're going to continue working on building gate-based universal machines and try to make the hardware more accurate and dip our toes into fault tolerance and error correction. But this is, I think, a very active field of research, and still everybody's at very, very early stages of this.
Alireza, how can people get in touch with you to learn more about your work?
They can reach out to us through LinkedIn, through our website, through Twitter. They can, if they want to talk to me in person, I'm both on LinkedIn and on Twitter, and I'm responsive.
Excellent. Well, thank you so much for joining me today.
Thank you very much, Yuval.